objective of this video is to understand the differences between acidity and acid strength. Acidity means the ability of a substance to function as an acid. According to Bronsted and Lowry acid-base theory, acid is a species that will donate proton or H pluses. So acidity simply reflects if a substance can donate or not these H pluses. Will it donate or not? And how much it will donate. So this is actually based on the concentration of H pluses. Acidity reflects the concentration of H plus. How we determine the acidity, we use this generalized formula. We take the negative log of the H plus concentration. In place of X in this general formula, you can plug in the H plus or the proton concentration. So that means if you take negative log of H plus concentration, we call it as, in place of X, just plug in H. So what represent or reflect acidity? It is pH. So pH tells you whether a substance can act as an acid or a base. Now in pH we have a scale from 1 to 14, and you can see there are certain everyday substances listed. Some of them can function as acids and some of them function as bases. And you can see the substances functioning as acids show smaller pH numbers, and the ones that function as bases have higher pH values. For example, if we take H plus concentration to be 0.1, take the pH, plug in the numbers, take negative log of H plus concentration, now it's 0.1, you will get your pH as pH 1. So if H plus concentration is going to be 0.1 m, it will have pH 1. What if your H plus concentration is 0.01 mole? Do the same math. Plug in this number 0.01 in place of H plus concentration. You will get pH 2. Now what you see is, as your H plus concentration decrease, when H plus concentration decrease, the pH number increase. So what it means is, small pH values reflect more acidic solutions. It means more acidic. If you have a large pH, it means it is less acidic or basic. Remember, pH is the feature that reflects the acidity of a substance. And the acid strength means how strong the acid is. Now this acid strength is reflected by the Ka or the pKa. You can use both of them interchangeably. Now let's see how you get pKa. Again, use the general formula. In place of X, now you plug in Ka. The general formula is Px is negative log X in place of X, plug in Ka. So pKa means negative log Ka. Now you know what Ka actually means. Ka is the acid ionization constant. If you have a large Ka or larger than 1, it is large Ka. A large Ka reflects strong acids. For example, if you substitute numbers, you will see the same trend over here. If you have a larger Ka, it will give you a smaller pKa. So strong acids have larger Ka. It means the stronger acids are going to have small pKa. And then in weak acids, your Ka is usually very small, smaller than 1. And when your Ka becomes smaller, when you get negative log of a small number, your answer is going to be large. So weak acids will have small Ka but large pKa. Now comparing the relative pKa or the Ka values, you can directly say whether an acid is strong or weak. Again, if we go into this chart, you can see the strong acid, Hi, HBr, chloric acid, hydrochloric acid, perchloric acid, sulfuric acid. You can see the regular strong acids. You can't even see the Ka values. Why? They're so large. They're so large, we sometimes even don't report them. However, when you compare the weaker acids, you can see the magnitude. The 10 to the power is negative values, meaning they are small numbers. And see what your Ka values are. When the number gets smaller and smaller, you can see the pKa value getting larger and larger. So that is one way we can show the acid strength. So acid strength simply tells you how capable this acid in dissociating. So acid strength reflects the ability to dissociate. You can express the basicity and base strength in similar terms. Now for bases, we generalize bases as hydroxides, species that can release OH minuses, which take in a proton. So any species that accept a proton can function as a base. So in place of this X, you can write OH. So what we can write to show the basicity is POH, that is negative log the concentration of hydroxides. You will see the same trend you observed for pH. If you have large OH concentration, larger the OH concentration, the smaller your pOH is going to be. And if you are going to have small OH concentration, that will lead to a large pOH. The base strength, again, the Kb or pKb. Now, pKb can be written the same way you wrote pKa. That is, substitute Kb in place of X. When you write the expression like this, you get the pKb value. Again, Kb, if you have a large value, if Kb is larger, that means it is going to be a strong base. And strong bases have small pKb. If Kb is large, your pKb is going to be small. And if you have a Kb which is small, what it means is you're working with a weak base. If your Kb is small, when you take negative log of Kb, you get pKb. So your pKb is going to be large for a weak base. Now we are going to see how these terms Ka, pKa and Kb, pKb and pH, pOH are connected to each other. Earlier, you came across this equation and we have derived how and you have looked into how we got this relationship between Ka, Kb and Kw. Now, if you try to turn everything into pKa, pKb and pKw, remember what you use is px is negative log x. Convert everything into that form. Take negative log of everything. So negative log Ka, and we have the multiplying sign which becomes a plus when we convert this whole equation into log terms, and you have Kb, take the negative log of Kb, and you have Kw, take the negative log of Kw. What this means is pKa plus, and what this means is pKb, and what this whole term means is pKw. Now this is another important expression that you are required to know. At 25 degrees Celsius, I mentioned that Kw is found to be this value at 25 degrees Celsius. So I would just keep on writing the number. So I'm going to take the negative log of this value at 25 degrees Celsius. What will you end up? If you do the calculation, you will get 40. So pKa plus pKb equals pKw, which equals to 40 at 25 degrees Celsius. Now in a previous video, you have come across again how we got this expression. Now again, what we are trying to do is trying to take the negative log of everything. Take negative log of H plus concentration, multiply, turn into plus sign, take the negative log of OH minus, negative log of Kw, and this is equal to this number at 25 degrees Celsius. So again, you can plug in the negative. This is also equal to this value, negative log 10 to the power minus 40. This whole term means pH, which we looked in previously, and this whole term means pOH. This means pKW, and take negative log of this term, you will get 40. And this is also an expression that you are required to know. Now all these numbers are given at 25 degrees Celsius. Why these equilibrium constant depend on the temperature? So it is important to note the temperature. If the temperature is not specifically given, we always assume things are taking place at 25 degrees Celsius.